Hello everybody, welcome back to Maths Miss Buick. We're still working on financial maths and this is the third video within pensions. I would recommend that you would watch video 1 and video 2 before you commence looking at video 3. So here we have Mary wants to fund that could from the date of our retirement give her €20,000 at the end of 25 years, AER of 3%. So we started up writing out our formula for our pension. So we have P is equal to P euro over 1 plus I to the power of T. And from this we're going to deduct what is our P euro, what is our I, and what is our T. So well, the P euro is €20,000 because that's how much money she wants to have every year from her pension. The I is the interest and we can see it's 3%, but of course divide by 100 to give you 0.03 in decimal, and T is 25 years. So here we have our three numbers. Now let's input those values in up here to our formula and make out a geometric series. So we have P is equal to 20,000 over 1.03 power of 1 plus 20,000 1.03 to the power of 2 plus plus 20,000 over 1.03 to the power of 25. Now you can see here in this case that our first term has a power of 1 on it because the pension is being received at the end of the year. Whereas if this says the start of the year, well then we'd have a power of 0 up here, so technically it would just be 20,000. So video 2 looks at an example where you have a pension at the start of the year, and this is video 3 where a pension is at the end of the year. So please make note when you are getting the pension. If it is at the end, recall it's power of 1, or if it says start, it's the power of 0 for your first term. So here we have our geometric series formed. Next of all, we're going to come along and write out what is our A, or R, and our N values. Well, the A is the first term, and we can see here it's all of this. So it's 20,000 over 1.03. Our R is our common ratio, so what is changing on the top as we multiply from term to term, we can just see there it's just a 1. On the bottom, we say what's being multiplied as we move from the denominator from term to term, and you can see there it's 1.03. And then our N value is the number of terms we have, and it is 25. So we must input these values now into our geometric sequence formula. So we have the formula Sn is equal to A 1 minus R to the power of n over 1 minus R, and don't forget the R is inside of the bracket. So let's input these values in now. So we have S25 is equal to A, which is 20,000 over 1.03 bracket 1 minus 1 over 1.03 all to the power of 25, and all divided by 1 minus R, 1 minus 1 over 1.03. So let's go to our calculator now and let's input this to get a value. Now, I have no problem where you put it all into the calculator in the one go, but you have to make sure you type in exactly what you see. So I'm just going to type it out here and show you exactly then what I have in my calculator. 1.03 power of 25, close the bracket, all over 1 minus 1 over 1.03. So you can see here, I've exactly, if I move this over here, you can see I've exactly typed what is written down on the board and what is in the calculator. So let's now press the equals button and we can see we get this number here. So 348,262. So €348,262.95. And of course, if they wanted to the nearest euro, of course, this 2 would now become a 3. So there we have it. That is our final overall answer, and video 3 completed.